When a quadratic function is in the form f of x equals a times quantity x minus h squared plus k, we call this standard form. Even though it doesn't look like the standard, what we'd think of as standard form, technically this is called standard form. And there's a certain sequence of steps to graph something in standard form, right? So let's look at this here. This is taken straight from the text because it's a lot to write and my handwriting isn't awesome. Okay, so here's our form, ax squared. Okay, so here's the form we're interested in. This is a so-called standard form. The vertex is h comma k. So one thing to note is that because of this negative sign here, when you go to do your vertex, the h is going to have a different sign, and then the k is going to have the same sign. And I'll say what that means in an example. Okay, so we'll get to that. This a bit out here, if that's greater than 0, it opens up. And if it's less than 0, it opens down. Okay, so we can imagine that. And we also have this axis of symmetry. This just goes through the vertex, the h from the vertex. It's just x equals h, whatever our h term is. It's the same h that comes from our vertex. Okay, this still doesn't tell us how to graph these. It just gets us started. So let's try an example. Let's graph f of x equals 2 times the quantity x minus 4 squared minus 2. Okay, so the first thing we do is identify the vertex. Okay, so the vertex is h comma k. Well, since this is of the form x minus h, our h is 4, and then our k is minus 2. And that's what I mean by different sign, same sign. You basically look at this, you change the sign to go into the 4, to go into the first slot there, and then for the k you keep the same sign. That's one way to look at it, or you can just keep going back to this formula up here, x minus h squared plus k. Okay, so there's the vertex, 4, negative 2. Next we determine if it opens up or down. Well, 2 is positive, so it opens up. One other thing to say about this 2 in the front here, since the absolute value of 2 is greater than 1, this is going to be narrow. 1 is kind of the cutoff point, right? When absolute value of this leading coefficient is greater than 1, it makes it narrow. If it's between 0 and 1, it makes it wide. So for instance, if this was 1/2 out front, that would be a wider parabola. Okay, so let's get to graphing this. We start with our vertex at 4, negative 2, so it's right here. We know that it opens up. Okay, so it's going to go something like this, but we don't know what yet, but we just know that's going to be the general shape. So let's find out more information. The way you get a second point on this kind of graph is to start with your vertex and then take your x value and go 2 places over. Sometimes you can just do it with 1 place over. I'm going to do it in 2 places over in either direction. So for instance, I'm going to go to 2 here in the x value, right? An x value of 2. And I'm going to put in 2 and see what y value I get. So let's do it. So let's do f of 2 to see what y value comes out with 2. That gives us 2 times 2 minus 4 squared minus 2. Well, this is 2 times negative 2 squared is positive 4 minus 2, which gives us 8 minus 2, 6. Okay, so what this tells us is it gives us a new point, 2, 6. And it's just one way that you can approach these. It gives you a second point here. So let's erase what we have here. Okay, so now we know that we have the point 2, 6. So 2, and it goes up to 6 like this. Now, anytime we plot one point, we get a second point for free. That's because of the axis of symmetry. So the axis of symmetry is a vertical line that runs right through the vertex. Okay, and usually it's a dashed line because it's not part of our graph. That is the line x equals 4. That's the equation of the vertical line. And it gives us a second point mirrored directly across that line. So this was 2 off the line, so another one happens right here, 2 off the line. So So over here we had 2, 6 on the left. On the right we have 6, 6. And that's enough for us to get our parabola. Note that it's a very narrow parabola. There we go. Which is what we expected because 2 is greater than 1. Off like that. Okay, note the nice symmetry right across that axis of symmetry. So that's how you approach these. You basically start with your vertex, and then you go off of the vertex in either direction, 1 or 2 points. Usually 2 is better, but sometimes it'll be so extreme that gets you way off the graph. If that happens, only go left or right by 1. Plug it in to get a y value, and then graph that second point, and then mirror across to get the one on the other side, across that axis of symmetry.